All right, the first section in chapter 8 is all about the geometric mean. So the geometric mean says for two positive numbers, a and b, the geometric mean is the positive number x where the proportion a to x is equal to the proportion x to b, and that's true. This proportion can be written using fractions, so typically we could see it as a over x equals x over b, or when we go through and solve that proportion for x using cross products, we end up getting x equals the square root of a times b. And that's actually what we're going to be looking at. So I'm going to draw a triangle off to the side just to show you what this looks like in the triangle, because it all has to go back to those proportions that we learned about before when we were creating proportions in triangles and proportional parts. So if that little piece is A, and I'm going to put some right angles in here, okay? And this section over here is B, and maybe I should color code these for us. So let me get all right, so this segment, that's our B, and then this vertical signal, that's not a very good color to choose. There, now we can see the green. That is actually our X. So it says X is equal to, when we cross multiply these, A times B, I'll just use black for the square root. All right, so pretty much you just have to multiply those two numbers together, take the square root, and then that is going to actually be what that's equal to. Because if I set up the proportions and explaining this, it would be the short leg over the long leg. So let me do that. Let me do our short leg over the long leg of one triangle is equal to the short leg over the long leg of the other triangle. So using this right here is going to be my small triangle that I have, and this one here is going to be my medium triangle. So this is my small, this is my medium, and the big would be the whole big triangle on the outside. So the small triangle, the short leg is A, the long leg is X, and that is equal to the short leg now of this triangle is X over the long leg is B. And then if we were to go through and solve that, we get X squared is equal to A times B, so X is equal to the square root of AB. So that's just to give you an understanding of why it is what it is and why do we multiply them. All right, so now let's go back. We're going to pull it away from that triangle for a second. Like I said, I just wanted to show you that so that way you get an understanding, but we're just going to just plain look at numbers at first. So it says find the geometric mean between 2 and 50. So 2 and 50. So geometric mean, that is X equals the square root of A times B. X is what our geometric mean is, so that's the variable used to represent it. So we have to take 2 times 50 and then square root that. So 2 times 50 is 100. Square root of 100 is 10. Okay, so X is equal to 10 in that case. For the second example, again, find the geometric mean between 25 and 7. So X is equal to the square root of 25 times 7. 25 times 7 is 175. And then when we square root that, we get approximately 13.2. And you could just simplify that radical if you wanted to. All right, so take a few moments, pause the video, try both of those your turns. All right, so you can see for the first your turn, we got X is 6, and for the second, we got 8.9. All right, so now we have a couple theorems here to look at. It says if the altitude is drawn, remember the altitude is just the height, from the vertex of a right triangle, from the right angle of a right triangle to its hypotenuse. So from there to there, then the two triangles are similar to the given triangle and to each other. So that's going back up to this triangle up here that I drew. And theorem 8.2 says the measure of an altitude drawn from the vertex of the right angle to its hypotenuse, so again from Y to W, it's the geometric mean between the measures of the two segments of the hypotenuse. So again, just going back to what I stated up here in that first little example I gave you. All right, so let's move on to the next problem. Example 3. And I do want to say these notes are sort of long today, so I apologize. Example 3, it says in triangle ABC, B to D is 6. Oh my goodness, that's a tiny little segment. So 6. A to D is 27. We have to find C to D, so I'm going to call that X. So if you notice, C to D is our geometric mean. So that's going to be X equals the product of those two segments. So 27 times 6. When we multiply 27 and 6 together, we get the square root of 162, which is approximately 12.73. Okay, again, you could go through and set this up as a proportion. We could do BD over DC equals DC over AD. And substitute the numbers in, solve it, and again, you will get the 12.73. So pause the video, take a moment, try the your turn, and then come back. All right, so you should get that the geometric mean, or in this case X, is approximately 8.5. All right, we have a couple math story problems to look at. So the first one says Miss Alice Patch is constructing a kite for her son. She has to arrange perpendicularly two support rods, the shorter of which is 27 inches long. So this one here, 27 inches. If she has to place the short rod 7.25 inches from one end of the long rod in order to form two right angles with the kite fabric, what is the length of the long rod? So we are actually going to be searching for that entire length right there. So what I'm going to pull from this is one of the triangles. And by one of the triangles means one of those half triangles that make up the kite. So I'm going to redraw it over here, and then we'll put in the lengths that we know. All right, so I need one more line there. So we need this line. And the reason we need that line is because that's the shorter rod that goes across, because we know the length of that shorter rod is 7.25. Or I'm sorry, the length from the one end of the long rod where it intersects the short rod is 7.25. We have to find this other side over here because it says what's the length of the long rod. So the 7.25 plus the X is the length of the long rod. So we'll write that over here. So the long rod, to find that, is 7.25 plus whatever I called X, okay? So if we knew this length here, we'd be in good shape. So if I look over here, well, I don't know what that piece of it is, but I do know the whole piece, the whole length of that short rod is 27 inches. So we know facts about kites, so we know that's actually split in half. So half of 27 is 13.5. So I can call this right here 13.5, and then look, we can set up the geometric mean to solve for X, substitute X over there, and we'll be good to go. So now let's number these now that we know what we have to do. So 13.5, and I hope this isn't going to confuse you, but I'm going to call that something other than X, only because we have been using X to represent our geometric means. I'm going to call it B. So typically it is X equals the square root of A times B. So in this case, X is 13.5. A is 7.25, and B, I kept B. So now to solve this for B, we need to eliminate that square root symbol. So in order to eliminate the square root symbol, we need to we need to square both sides. So 13.5 squared is 182.25. So 182.25. And that is equal to 7.25b. And now we need to divide both sides by 7.25. And when we do that, we get 25.14. All right, so now we have b. So now we need to find the length of the long rod. So we need to take 7.25 plus 25.14. And we get the length of the long rod is 32.39, and that is in inches. So if they wanted us to round this, we could say 32.4 inches. All right, so you're going to complete the your turn in the same basic method. So take a moment and try that. All right, so in this case, I'm sorry, I have one. I should put a 2 there. Should be 230. All right, so the length of the plane is approximately 230.64 feet. It does say to the nearest tenth of a foot, so we should do 130.6 feet. All right, so moving right along, last example. It says if the altitude drawn from the vertex to the vertex of the right angle to the hypotenuse, so that y to w there, then the measure of the length of a leg is the geometric mean between the measures of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So let me erase that and let's take a look at what this says. It says x to z, so the whole big length, over x to y, so hypotenuse over long leg. So I'm going to write hypotenuse over long leg is equal to, let me get a different color, xy to xw. So it's saying those two little pieces. And then it also goes fit with the smaller triangle there. All right, so there are a couple different ways we could do this problem. One thing we do not want to forget about, which is sort of ironic because this is geometric mean. And if you, well, not that you guys have the book, but if you look this up, they could show you one way to do this problem. But I'm going to approach this realistically, knowing that section 8.2 is Pythagorean theorem, and we all are very competent with Pythagorean theorem. You guys all do very well with it. We're just going to use Pythagorean theorem to answer these questions because that's honestly what you're going to use. So we can't forget Pythagorean theorem. So we're going to use Pythagorean theorem when we are able to, and then we'll use geometric mean when we need to. So it's asking us to find C and D in this triangle. All right, so we really could find either first. Since C comes first in the alphabet, guess what? That's what I'm going to find first. So I'm going to do step 1. I'm going to put, we need to find C. So if I'm looking at C, that's a part of a side. So I'm going to use geometric mean. So I'm going to write geometric mean there so that we don't forget. So I'm going to do x equals the product of A times B. X in this case is 10. Oh, sorry. Putting random letters in here. Okay. So x is 10 equals 5c. So I'm going to square both sides to eliminate that radical. So 10 squared is 100. And if I divide 100 by 5, we get C is 20. So we found C. C is 20. Now, I'm going to, I see a whole bunch of right triangles here. And when I look at D, well, that's the hypotenuse of this smaller, or the smallest right triangle. So we know that A squared plus B squared is equal to C squared. So that's our Pythagorean theorem. So fill in what we know. I'll just say that that's A, that's B. So A is 5, so 5 squared plus 10 squared is equal to D squared. So 25 plus 100 is equal to D squared. 125 is equal to D squared. And then if we take the square root of 125, we get approximately, sorry, I should put approximately there, 11.18. And there are no units, so we are finished. We found C and D. So take a few moments, try this last your turn, and then come back and double check your work. All right, so you can see that I got E to be approximately 17.9 and F is approximately 8.9.